Kirchhoff's laws. Effective resistance of the simple circuits labeled A and B can be reduced to series and parallel combinations by using Ohm's law. But Ohm's law cannot be used to solve complicated bridge circuits having more than one source of EMF. To solve such bridge circuits, German physicist Gustav Robert Kirchhoff put forth two laws, namely Kirchhoff's first law or junction rule, Kirchhoff's second law or loop rule. Bridge circuits terminology. Junction. A junction in a circuit is a point where three or more conductors meet. Junctions are also called nodes or branch points. Loop. A loop is any closed conducting path. Kirchhoff's first law. It states that the algebraic sum of the currents flowing into any junction is zero. That is, sigma delta I is equal to zero. Consider a circuit having 5 current elements meeting at a point O with currents I1, I2, I3, I4 and I5. To take their algebraic sum, we assume the sign convention. The current flowing towards the junction is considered as positive. The current flowing away from the junction is considered as negative. Applying the sign convention, I1, I3 and I5 are positive and I2 and I4 are negative. That is, I1 minus I2 plus I3 minus I4 plus I5 is equal to 0. Or I1 plus I3 plus I5 is equal to I2 plus I4. The total current towards the junction equals total current away from the junction. This law is in accordance with the law of conservation of charges. Kirchhoff's second law. It states that the algebraic sum of the potential differences in any loop must be equal to 0. That is, the sum of the EMF of the sources of energy in the circuit and the potential drop across the resistive elements is equal to 0. Let us see how the loop rule is used to solve the given bridge circuit. First, draw a circuit diagram to represent the circuit. Mark the direction of flow of current through each branch of the circuit. Then apply the sign convention. According to the sign convention, the EMF of the source is taken as negative if we move from the positive terminal to the negative terminal, and the EMF is considered to be positive if we move from the negative terminal to the positive terminal. The potential drop across any resistor is taken as positive if we move in the direction opposite to the direction of flow of current and vice versa. Consider the circuit shown here. In a closed loop, ABEFA, minus I1 plus I2 into R3 plus E2 minus I1 R2 is equal to 0. In the loop CBEDC, minus of I1 plus I2 R3 plus E1 minus I2 R1 is equal to 0. Comparison of the Kirchhoff's rules.